In this video, what I want to do is show you how you would calculate three of the primary metrics that we use for capital budgeting decisions. I'm going to work off of the forecasts that I developed in the forecasting section, and I am going to rely on a weighted average cost of capital. I guess I'm going to use one from my prior example. But anyway, what I will be showing you is net present value, internal rate of return, which is IRR, and then I will talk to you about the payback period. I won't be doing that in Excel. As it turns out, payback period is much easier to calculate on the back of an envelope than it is to calculate in Excel. So that's kind of where we're going. The starting point for this is that we need the cash flows from assets. So that would be operations cash flows, obviously, those sorts of things. But in our case, what we're looking for are, obviously, we want the operating cash flows. We want any sort of cash flows. Sorry, I'm pulling the wrong stuff, aren't I? I want primarily operating cash flows. I do not need the cash flows from capital spending per se, other than that I need those for the investment amount at the beginning. And I do need changes in working capital, non-cash changes in working capital, because basically those are cash flows that we will have to consider in terms of the value of the opportunity. And so together, those all become the total cash flows from assets. You'll notice you have an investment value, you have your cash flows throughout, and we have a terminal value calculated to reflect, in our case, from year 11 and beyond, simply because we don't pay off all of our debts and depreciate all of our assets until year 10. And so there is a bit of a change in year 11, and we would expect that to continue on. So first thing that I want to do is I want to go ahead and set up let's just call it a period line. And this is period 0, period 1. Make it, we'll just go 1 plus 1. And the reason I do that is that reflects the number of periods backwards each of these cash flows has to be discounted to present value. And so a net present value is a pretty straightforward situation where what we're doing is trying to solve, if you will, for a rate that is the value of the project after we deduct off the initial investment requirements. And so we need the period. We are going to need a discount rate. And I don't remember that from my other project, so I'm going to go open that up in terms of cost of capital real quick and see if I can figure out what we did there. Let's see. Sorry, wrong one. My bad. Need to look at the WACC example. There we go. Looks to me like when we did the WACC example, putting everything together, I came up with a WACC of 12.5%. So that's what we'll use in this calculation. 12.5%. It's important to put the percent, otherwise you're going to have a problem. So what we want to do is we want to take all of these cash flows and we want to discount them back to the present at the discount rate, at the accepted discount rate. So literally we'll go through this process. I will calculate this separately for you so you can see it. We'll calculate the discount factor, and let's just call that is equal to 1 divided by 1 plus the discount rate, and it'll be important for me to put this here because I want to drag the formulas, raised to the power of however many periods out it is. Since this is 0, period 0, the discount factor is 1, meaning we're not doing any discounting then. Did something wrong there, didn't I? Let's see. I should have been putting the $sign in front of the column because we're dragging to the right here. Sorry about that. Okay, so there's our discount. And that discount factor, basically, to put that in a context, and I'm going to kind of format those, I think, as percentages. Maybe a little bit more than that. But to put that in a context, what that, for example, at year 9 at this discount rate, what that says is getting a cash flow in year 9 is only worth 34.6% as much as if I got it today. Getting a cash flow in year 11 is only worth 27.4% as much value as if I got it today. And so, obviously that's a big drop off now, not from there to there, but it's a big drop off the further out in time you get. So now what we want are the discounted cash flows. All right, and that is equal to just our cash flows times our discount factors. Again, the first one's pretty easy because discount factor is 1. We drag those to the right. So what we've calculated is the values, if you will, for all of our cash flows going out to the various years. And we also have this one big value that is year 11. Okay. What we don't have is we have not properly reflected our terminal value in that. So this is the cash flow in year 11, but it is not the cash flow for everything from year 11 and beyond. And so what I'm going to do is put out here another year value at year 11. It'll have the same discount factor. And we'll call this my terminal value. Okay. And the terminal value we calculated was $450,000. We basically estimated about a $90,000 a year result and divided it by 20% discount rate at that point in time. So for us, it's equal then to this $450,000 times this factor. So $123,000. So those are our discounted cash flows. Our NPV, in this case, becomes, we simply sum up all of those cash flows, all of them including the terminal value. Okay, and so we get a number in this case of $141,232. What that says is the fair market value of our project, taking into consideration everything else, is $141,000. Think of it slightly differently. If you're a company, taking on this project adds $141,000 to the value of your company, and assuming that a 12% discount rate is appropriate. And so that's net present value. The second thing that we want to do is an internal rate of return, often referred to as IRR. You set that up basically the same way, and we'll go ahead and just put the 12.5% in as a starting point. Quite frankly, you'll go through pretty much the same process. And so I think I can get away with this. Let's see, I probably need to make this change. Put a dollar value there. I'm just going to go ahead and borrow this discount factor. Okay, and we'll drag that thing all the way out. And we're going to do the same sort of equals that times that. I know this looks repetitive, but bear with me. Take that all the way out. Once again, not quite sure why that did that. We should be getting about the same numbers. So that times C90. Yeah, it's important that you do it times the actual cash flows, not the ones you've already discounted once. Okay, didn't like that. That's okay. So we're going to calculate that whole thing out. And again, we'll do the equals the discount factor times the terminal value. Okay. And again, we're going to do a sum. So NPV. So you can see I basically, this is discounted cash flows. You can see I basically have done everything that I've already done above. And you may be thinking to yourself, why would he do that? And the short answer is that you do set the problem up the same way. It's just you go for a different goal. So with an IRR, let's highlight that for the NPV, and we're going to highlight this. With the IRR, instead of solving for the net present value, you solve for the discount rate that will make the net present value equal to 0. So we'll use goal seek for that. Go over to the data tab. Why is that not doing that? Oh well, there it is. I'll just do it that way. Go what if, goal seek. And we want to set cell C96 to 0 by changing the value of the discount rate. So it calculates through. Not sure what's going on there. Sorry, made a mistake. C94. Sorry, discount factor. This discount factor wasn't changing is the problem. Needs to be 94. Correct? 93 maybe. 93. My bad. So we'll drag that formula out again. So what was going on is that because I had not anchored it to the right source, it wasn't making the change. Let's see. So B93. Why is that not doing that? B93 times 1 plus. Sorry, I'm not following it here. Let me just recreate this. Equals 1 divided by 1 plus this discount rate. Dollar. That way there's no question. Raised to the appropriate power. That becomes our discount factor. So should be able to apply that over. Why is that not working? Probably because of what I got in here. Let's just do 12.5% again. Yeah, that's what's going on. So it was probably right before. Oh well. Good for you to see how somebody that's done it for a while still makes mistakes. All right, now let's go back through and do this what if again. Goal seek. Yeah, we're going to take that value, set it to 0 by changing the discount rate. And it's going to cycle through. And it's going to you see how it set the NPV to 0. Well, so in order for that to happen, you have to have a discount rate of 19.47%. And so that's basically saying that the rate of return on this project is 19.47%. Not too bad. The last thing that you would need to do here is to calculate a payback period. Again, I'm not going to show you how to do it in Excel because that seems a little bit silly. It's actually a somewhat tedious thing. The concept of a payback period is that you want to take the cash flows and you want to build up this cumulative sort of cash flow until you get to the point that you've paid everything off. And so what you want here is you want the cumulative cash flows. So it's equal to that, equals to that, plus And again, we're not using discounted values here, we're using actual values. That's the standard payback. So you can see it's paid some of it back. And you just keep dragging that out, all the way out. And what you're going to notice is it finally pays everything off somewhere along in year 6, and there's still some left. And so your payback period becomes 5 years plus effectively the ratio of how much got paid off. And so in our case, we would say you paid off equals this much minus this much, all of that, divided by the total amount that you got. And so what it's saying is it actually took you about 85% of the year, so 0.85 years in year 6 to pay the rest of it off. So your payback period in this case would be 5.85 years. And so what that says is it's going to take you roughly 5.85 years to pay the thing off. Again, if you had to do that in Excel, it's a little bit more complicated formula than just doing it back of the napkin. So that's why we do it that way. Anyway, so that's how you calculate it.